Welcome. This video will help us understand how to describe center and spread for numeric variables in SAS. Remember, we have two types of variables. We have those categorical variables and numeric variables. We've already talked about how to summarize categorical variables numerically. Now we're going to look at how to summarize numeric variables with numbers. Numeric variables, remember, they have to have numbers for their entries, of course, but then you also need to be able to do math on those numbers. What we try to do is describe the distribution of our numeric variable. And if you have one variable by itself that's numeric, the things that you try to describe are given here. Shape, center, and spread. Those are the main things that we try to do. For shape, we don't really do that with numbers too much. We tend to use graphs to do that, so we'll look at that later. But we'll focus on measures of center, such as the mean and median, and measures of spread, like the variance, standard deviation, quartiles, and IQR. When we start talking about two numeric variables, there are other things that we care to look at, such as the linear relationship between the variables, for instance, and so we'll look at that in a little bit as well. But for this video, what we're going to focus on is I have a single numeric variable, and I want to summarize that variable's center and spread. We need a data set, of course. In this case, we'll read in a new data set that we haven't done before, and this is a data set on carbon dioxide uptake in grass plants. So the response was the CO2 uptake, so this was numeric. And there were a couple variables measured with this study. Some of them were categorical, some of them were more numeric in nature. One of them that was categorical that we'll look at later is the environment that they used, whether chilled or non-chilled, and that's going to be called treatment in this case. And then they also specified and measured the ambient CO2 to make sure that that wasn't a problem, or sort of a confounding variable, and that variable is measured in consts. So these ones are both going to be numeric, and we'll look at those. But the main variable that we'd want to summarize for this data set would be the uptake variable, because that is our response variable. That is the variable that is characterizing performance for our data set. This data set is available in our shared folder for this module, so the path to it should look something like what you see here. We'll use a libname engine. Since this is an XLSX file, we'll use a libname engine to just gain access to it, and then we'll set that data set and copy it into a SAS data set. So here, libname statement, to gain access to it, we're going to copy that particular sheet of that we have access to as a new data set in our working library called CO2 data. Let's just double check that this data looks like it read in correctly. We'll use a proc print, just look at the first 5 observations, and then also proc contents to see how the variables are stored. Here's the proc print output. Again, uptake, this is our response variable. This is the one that we care the most about. You can see that it is numeric, and it does make sense to subtract these uptake values, so that's good. Concentration, likewise, is numeric, and so we'll deal with that one as well. We have a couple other categorical variables that can be useful that we'll see how to utilize later on. Proc contents tells us how these variables are read in. Again, we have 2 numeric and 3 char. All right, we want to measure center and spread. The main ways that we do that would be the sample mean and median, sample variance, standard deviation, quartiles, and IQR for spread. Well, there are a couple different procedures in SAS that will allow us to do this. One of those is Proc Univariate. Proc Univariate is kind of like I want everything thrown at me. So you're not specifying exactly what you want, but Proc Univariate is going to give you most everything that you could ask for. Not usually the procedure you want to use, but it's a good starting point. Here's the basic syntax for using Proc Univariate. You have the Proc Univariate statement to start it, and of course there's going to be options. We're going to specify our data equal option here. Again, note the syntax for the options. It comes right after Proc Univariate. Just like most of our procs, we can use a by statement if we want. We would need to sort our data first. There's a class statement that we'll look at that we could use in lieu of by to do some different summaries by different subgroups. And then there's a histogram statement that's commonly used here that will produce a nice histogram. We'll use proc sgplot instead of proc univariate to do that though. And then we have the var statement. This is going to be the one that we care a lot about. This is going to be where we specify our variables to actually summarize. And there are no options given on this one, but we'll just be able to specify what variables we want. If we don't specify any variables, it's just going to do any numeric variables in our data set. All right, so here's some code to analyze and summarize that uptake variable. There's a whole bunch of output that gets thrown at you. So it gives you a whole bunch of things about what they refer to as moments. and then basic statistical measures. And so this is really the area that we want to focus on if you're just doing basic statistics. Sample mean, median, mode, and then measures of variability as well. SAS will also give us quantile information. Quantiles are just the value from the data set that has a certain percentage of the data less than or equal to it. So for instance, the median, which we have over there as well, this has 50% of the data below it, 50% of the data above it. The 75th percentile or 0.75 quantile, or Q3, lots of different names for it, this has 75% of the data less than or equal to it, 25% of it bigger. So these are giving us sort of ideas of the spread of the data set in some way. It also gives us some basic statistical tests. Don't worry about that if you don't know statistics yet, but basically it gives us a test for the mean being 0 versus not being 0, and then also some information about the largest and smallest values. All right, so Proc Univariate just throws everything at you. Not necessarily great, especially if you're going to try to put this stuff into a report and you don't want to sort of retype these tables. What other options do you have? Well, Proc Means gives the same kinds of info, same summary stats that we might want, but only what you request. And here's the basic syntax for Proc Means. And what we want to focus on here is this statistics keywords. This is where you'll describe or put exactly which statistics you want reported back to you. But most everything else for this has the same syntax as what we did before. Here is some nicer looking output that only returns the things that I want. I'm going to use proc means, data equal, and then here I'm requesting the different statistics of interest. And then I'm using an option here to say I only want 2 decimal places in my output, just to make it look a little bit nicer. And you can see the output given below. This is a lot nicer if you were just trying to, if you knew exactly what you were going after for your data set. Okay, we now can summarize center and spread for a numeric variable. What we often want to do is not just summarize that variable all together, but maybe we want to break that variable into chunks corresponding to different values of a different categorical variable, and do the same summaries on those subsets of the data. So we have this other variable in there, treatment, chilled or non-chilled, and so maybe what we want to do is compare the center and spread values for the chilled group to those of the non-chilled group. There are really 2 ways to do this, although you could think of some others, but a by statement will do this for us. This requires us to sort the data, and then within our actual proc univariate or proc mean step, we use a by statement to say, do this by that variable, and it will do the same summaries for each setting of it. Or we can use a class statement, which does not require sorting, produces slightly different looking output, but generally speaking will do the same thing. There are different efficiencies associated with these, but those are beyond us at this point. We'll just see that we can use both of them to do this kind of thing. First, let's do it using the by statement. Again, if you're going to use the by statement, you first need to sort your data using proc sort. Here I'm going to proc sort on my CO2 data, and I'm going to be overwriting this data because I am not specifying an out data set. So I'm going to overwrite my data set by the sorted data set, and I'm sorting by treatment. Then I'm going to run proc means, and I'm just going to include that same variable that we had up there in a by statement. This will just produce output that is for each one of those settings of that treatment group. Since treatment here only has 2 settings, we now get output for chilled and output for non-chilled. Really useful. We can now compare the means for the 2 groups and say, looks like the chilled group has less CO2 uptake than the non-chilled group. If we want to use a class statement instead, we don't need to worry about doing that sorting business first. We just do class treatment, and then we get output that looks like this. And this maybe looks a little bit better and is a little bit easier to compare as well. We now have a row for the chilled and a row for the non-chilled, and now we can compare those summary stats across there. You can also do this for multiple subgroups. You don't just have to think about doing it for one categorical variable. You can do it for more than one. If you're going to do the by statement, you just need to sort by more than one variable. If you're going to do the class statement, you just need to list more than one variable there. Here we'll do the same summary stats, but for all of the combinations of treatment and concentration. Concentration was a numeric variable, but it only has a couple settings, and so it can make sense to do this kind of thing here. And so we can see now that we have for every treatment and concentration combination, we have the summary stats, just like we have it down here as well. And Again, what this allows us to do is really have an idea of looking at the center of the data set. So if you're going to use the mean to summarize your center, you can see how that is changing based off of the concentration of CO2 in the air. And you can see how that's changing for the concentration, not just for concentration, but also by the chilled and non-chilled groups. So this is a really useful way to summarize your data. Let's jump into SAS and let's summarize some numeric variables utilizing this kind of idea. All right, here we are in SAS. We're ready to analyze some data and summarize it in a meaningful way. Let's go ahead and summarize that online news data set that we read in a previous video and see if we can make any kind of meaningful insights into that data. The main variable of interest, what you might call the response variable for this data set, was the shares. And this is the number of times that whatever article was shared. And of course, you probably want to have the article with the most shares. So we're going to try to think about what variables are associated with having higher shares. Let's go ahead and use Proc Univariate. We'll just get everything thrown at us for starters. So our data here is going to be ncsu.mynews. And we'll just do the variable shares to start with just to see what it looks like. Highlight that and run it. Oh, variable share is not found. This must also still have a space before it. Annoying, but we'll deal. All right, log looks good this time. We look over here at the results. I know it's a little bit small. Let me zoom in a little bit. Again, the main table that we want to focus on would be the statistical measures. So we have a mean of 3,395 shares, median of 1,400. So that means that there must be some articles that were shared quite a bit because the median is much less than the mean, which means that there must be some very large values pulling that mean out. And then we can look at the standard deviation. That's hard to interpret here, but it's pretty large. So there must be some articles that have really large values. Okay, great. Well, how could we go a little bit further here? Well, let's use our class statement and let's try to think about some other variables that we could break this shares variable down by. Up here we have this isWeekend variable. So that might be interesting. Can we compare the distribution across the weekends? The weekend versus not weekend. So we'll add that to our class statement. We'll rerun that. Log looks good. We'll look over here at our results. Again, this is not kind of as nice as proc means and how it outputs, but we have one set up here for, let's see, this is weekend equals 0. So this is a weekday article. We see 3,318 to 1,400 for mean and median. Go down here. For the weekend, 3,900 to 1,900. So it looks like there are sort of more shares usually on the weekend. The median is higher than the mean. Of course, these are sample values. We're not doing any testing at this point. We could break that down even further. So we made this type variable. So maybe we do type. Actually, let's go switch to proc means, proc means, because it has a little bit nicer output. And we can just request what we want. So I'm going to add the type variable here. So we'll get this broken down not just by the weekend, but also by type. And now I need to specify which variables I want, or which summary statistics I want, since I'm going to switch to proc means. So let's just do mean, median, and standard deviation. Let's run that. Log looks good. And now we can focus on our results here. So on the weekend, we have weekend down here. These are the different number of observations we have in each one of these groups. Here are the means. Hard to say that there's clearly a difference between these. Looks like we range from about 4,000 to 3,600 on the weekend. Then we come up here. And it does look like maybe there's more evidence of a difference between the categories up here. We go from 2,900 to about 4,000, 2,800 to 4,000. So again, this gives us some idea of the types of information we can extract using these summaries. All right, to recap, doing our numeric summaries of quantitative or numeric variables, Proc Univariate and Proc Means can both do it. Proc Univariate is the one that's just going to throw everything at you. Proc Means is the one that's a little bit nicer if you know what you're looking for. And then if we want to do the same summaries across different categorical variables, we can use the by statement with a sorting and then a class statement if we want to do it that way as well.